Hi class, we are now in chapter 9.5. This is the quantum mechanical model. So this section is just setting up to understand what this new model is. So the quantum mechanical model replaced the Bohr model. The Bohr model was great in understanding the behavior of hydrogen atoms, but once we got into anything else, it actually didn't reflect the behavior of what we were seeing very well. The quantum mechanical model replaced the Bohr model early in the 20th century. So instead of Bohr orbits, we now have quantum mechanical orbitals, or you can just say orbitals. Orbitals are different from orbits in that they represent a probability map that shows the statistical distribution of where an electron is likely to be found. I'm going to explain in the next slides exactly what that means. So this means that there's a probability of finding an electron in a certain area over other areas based on evidence that has been repeated over and over again. We will never know its exact path. We will never know exactly where it is in this orbital, but we, based on enough information, believe that there's a higher probability it is here compared to somewhere else. So let's pretend it's a bedroom. You're in a house. We can say through enough evidence there's a high probability that this electron is in the master bedroom based on enough evidence that we have done through experiments, and not in the kitchen based on enough evidence to show that the probability is very low there. But it doesn't represent the exact path of where it is and as it travels through space. So it's likely to be found here and not there is what they're saying. So let me explain this with baseball. If a baseball pitcher pitches a ball, the catcher, if he's doing his job, will know exactly how to put his mitt up to catch it. You can see it, you can track it, you can trace it. However, let's pretend theoretically a pitcher can throw an electron. The catcher will not have any idea where it's at because we cannot see these. I know I just said that he could throw it, but now we can't see it because this is where this probability comes in. We never are supposed to know exactly where it is, but we can have a high probability of where it's most likely. So the pitcher will have no idea how to put his mitt, where to put it, in which area, left or right, up or down. But what we can do is through hundreds of experiments, we can keep track of how many electrons go over this plate. And as we do, don't ask me how, I don't know these experiments, how they could do this, we can keep track of the statistical pattern of where these electrons go over the plate. What area are they specifically going over the plate, and how many more go over this area compared to this area. That's a probability map, and then we draw it out on a map with dots. So that will show the probability, the highest probability, the more concentrated dots, where the electron's supposed to be, or we believe to be, in comparison to other places. So this is where we say there's a high probability that this electron is in this 20% of this orbital compared to the outside. It's got a lower probability that it's anywhere on the outside. So we can say we believe it's here based on probability or experiments, evidence, but not over here. That's what this new model, this quantum mechanical model is.